In this video, I'm going to go over the common student questions that come up in Math 102 in Chapter 3. So you can look down the selections here and see if your question is in here. I'm going to put timestamps on these sections so you can look down and scroll through and see where each new section starts, so you could quickly in the video go to a certain section if you needed to. 3.1, question 24. Here we're asked, is -9 a solution to this equation? So what we want to do is we want to replace all of the x variables with this -9. And when we do that, we always put a parentheses around these variables we're replacing. So what I would do is I would say, okay, first I put a parentheses here, and that's for where the x is, the -x. So I put the negative sign out front. Now I'm going to substitute this value of -9 inside. And what happens is if we put these parentheses here, it helps keep everything organized for us and makes it easier to do the problem. So let's see, I'm going to put another set of parentheses and put the -9 in there, -19. What I want to do now is I'm doing a check. Notice I've substituted the value in. Now I'm going to work each side of the equation independently, and hopefully when I come down here, the two sides will be the same. If they are, then I say yes, this is a solution. If they aren't, then I would say no, it's not a solution. Okay. So let's take a look here. So minus a -9, or another way to think of this is opposite of -9, is actually +9 plus 8. And here I'll multiply a -4 times a -9, which would give me a +36 minus 19. Run out of, well, we got one more spot here. Let's see. So 9 plus 8, that would give me 17. And 36 minus 19, 16, that is also 17. So we put a little check. And then we would say, yes, -9 is a solution. Okay. In section 3.2, question 33, what we're asked to do here is simplify this algebraic expression. So when we simplify an algebraic expression, we're following the order of operations. And so in here we have subtraction, addition, but we also have division. And so following the order of operations, I'd want to do division first. And notice the division works out nicely in each of these fractions. So I could say 6x divided by 2 would give me 3x, minus 9x divided by 3 would give me 3x, and then plus -20x divided by +5 would give me -4x. So let's see. Well, 3x minus 3x is going to be 0, so all I'm going to have left with here then is a -4x for my final simplified answer. All right, section 3.3, question 6. We're trying to solve this equation for c, which means we want to isolate it or get it by itself. Right now we currently are subtracting 2/5. That's what's keeping it from being all alone. So we want to undo that. So to undo the subtraction of 2/5, we add 2/5. And I want to make sure I do that to both sides to keep my equation balanced. So let's see, -2/5 plus 2/5, that's 0. So I've essentially isolated c on one side. Now -7/10 plus 2/5, I can't quite add those together because we don't have a common denominator. So let's do a little bit of work. If I look at the denominators of 10 and 5, that common denominator is 10. So really this -7/10 can stay just as it is because it's got the right denominator. Down here, the 2/5, I need to multiply the top and the bottom by 2. So that'd be 4/10. Now notice one thing that I did. This negative sign out front of the 7/10, I can put that negative in one of three places. We can put it right out in front of the fraction, right in the numerator of the fraction, or right in the denominator of the fraction. I think here it's going to be an advantage to think about that negative right in the numerator there. I wouldn't want to put it in the denominator because then I'd have different denominators, one positive and one negative. But if I move it up here, then it makes it real clear. This is a -7/10 plus 4/10. Well, when I add fractions with the same denominator, that denominator doesn't change. -7 plus +4 gives me -3/10 for my final answer there. All right, question 21. Again, we're solving this equation. I'm trying to isolate x. I would want to undo the subtraction of 7 first. So I add 7 to both sides. On the right side, I'll have 9x left. And a lot of times students get confused here as what to do because they go, well, -7 plus 7 is nothing. and they leave this blank over here, and that's a mistake. When we have nothing, we have a symbol for nothing. That symbol is 0, and we want to write that 0 in there, because now we can look at this side and say, all right, well, now I want to isolate x, get it all by itself. It's getting multiplied by 9, so I divide by 9, and we'd see that 0 divided into 9 parts is still 0, so we'd get our solution. So it's important to write this symbol for nothing, 0, because it helps us follow the same process and steps that we use when we're solving an equation. So make sure if something drops out, we write a 0 in its place. It will help you solve the equations. All right, still working in section 3.3. Now we're on to question 31 here. You're planning a month-long trip to Europe. Your cell phone plan will charge you 50 cents per minute. So let's stop right there. So we're going to get 50 cents per minute on top of the $40 monthly fee we're already paying. So we're going to get these roaming charges of an extra 50 cents per minute. So let's see, part A, in words describe how your cell phone bill will be calculated. Well, I would say we're going to get charged $40 plus this 50 cents for every minute we talk. Okay, so that's good for the words. $40 plus 50 cents for every minute we talk. And we'll put it on there. All right, part B, write an equation that represents the cell phone charges you'll incur during this month in Europe. Let C represent the cost and X represent the number of roaming minutes. So we're trying to write an equation here that represents the cost. So we'd say, okay, the cost of this cell phone plan is, well, we already wrote that in words. We want to have $40 plus 50 cents for every minute that we talk. Well, $40 is pretty easy, so let's go ahead and write that. That's just 40 plus 50 cents per minute. Well, let's think about that. If we spoke for 1 minute, we'd get charged 50 cents. 2 minutes, $1. 3 minutes, $1.50. Notice what I'm doing there as I'm repeatedly adding the 50 cents. So when we have a repeated addition, the way we deal with that is we use multiplication, remember. So if I take 50 cents, 0.50 times X, the number of minutes, that would give me a total for my cell phone bill. Notice if I talked for 1 minute, I'd have 1 times 50. 2 minutes, 2 times 50, 3 times 50, so on and so forth. Part C, now solve the following equation to determine how many minutes you can talk on your phone if our budget allows for $75 in phone expenses. So notice this is the total cost, that's 75. So that is going over here for the cost. So I'd say this, 75, oh, not 4. 75 is equal to $40 plus 0.5x. Now 0.50x and 0.5x, same thing. So now I want to solve this equation. So I would minus 40 from both sides. Come over here, and then I'd have 35 is equal to 0.5x. Divide by 0.5. And then x is going to be 70, and then we would want to say minutes. All right. Questions 34, 35, and 36, and we're asked here to find the area, and we're also asked to round to the hundredths place when necessary. So we're going to need a calculator probably to do some of these problems here, so I'll get my calculator out. All right, let's take a look at this first one, 34. Find the area of the rectangle. Well, here's the formula. It says the area of a rectangle equals L times W. When we write letters next to each other in mathematics, it means those things are getting multiplied together. Well, L and W, that is the length and width of this rectangle. So I'd say, okay, area is, and there's really no specification in terms of length and width. It seems like in general, usually people say this is length and this is the width, but either way, it won't matter. So we'd say L, the length, 16. Remember, when I'm substituting for a variable, put parentheses around it. So I put parentheses around that. And then W would be 10. So I put 10 in there. And I'm going to multiply 10 times 16. And that's going to give me 160. Now, notice this is feet here, feet times feet. So what this is going to be 160 square feet for my answer, because area is a two-dimensional measure. We measure area with squares. So what this is telling me is it's going to take 160 of these little squares that are 1 foot by 1 foot to cover this whole area of this rectangle here. So whenever we're reporting an answer for area, we always want to make sure we answer in square units, square feet, square inches, whatever we happen to be measuring with. Okay, let's look at 35 now. Here, area is 1/2 the B, which is the base of my triangle, right here, and H, which is the height of my triangle. Okay? I don't need these diagonal measures. All I need to find the area of a triangle is the base and the height. Multiply it by 1/2. So let's go ahead and plug these values in. So I'd have 1/2, and then I'm going to plug two values in here. The base, we said, was 30. The height is 12. Now, when I multiply three numbers together, I can multiply them in any order. I want to multiply them one at a time and take that answer and multiply by the next. But I can multiply in any order. I think here it makes a lot of sense to take half of 30 first. If I take 1/2 times 30, that's essentially finding half of it, which I know is 15. So now all I have to do is take 15 times 12 to get my answer. That's 180. And now I want to make sure I'm answering in square units. This M stands for meters, so then we could say square, whoops, put an R in there, square meters. Okay? Area of a circle. The area of a circle says, to find that area, we're going to take pi, which is a number, 3.14, and it carries on from there. That's why we have a symbol for that number, because we can't actually say that number if we tried to describe it, because it's a non-terminating decimal number. It goes on forever. So we take pi times r squared. Well, r is the radius of a circle. What they've given us right here is the diameter of a circle. We want the radius. Well, the radius goes from the center of the circle out to the edge. Well, if our diameter all the way across is 10 yards, then our radius from the center to the edge, which is halfway across, will be 5 yards. So that's the piece of information I want, is at 5 yards. So let's see, area is going to equal pi, and you got a pi key on your calculator, or you could just use 3.14. Either one works. I'll use 3.14 here for pi. It won't be as accurate as using the pi key on my calculator, but it will get me very close to the answer. So when we're calculating things like this, your answer might not be exactly what you find in the back of the book, because you may have used a different value for pi. So as long as we're relatively close to what's in the back of the book, we know that we've done our problem correctly. Okay? So pi times radius squared. We said the radius was 5, and I'm going to square that. Now, when we're figuring out what this answer is, we want to follow the order of operations. Notice exponents first, so I'm going to take 5 squared, which is 25, and then I'm going to multiply 25 times 3.14. 78.5, and then yards here, so I want to say square yards. Okay, section 3.4, question 15. We're asked to solve this equation for x. Well, this is a pretty complicated equation, so we're going to need all our steps. Step 1 is to simplify each side the best we can. So I'm looking at this side, simplifying it, looking at this side and simplifying it. So let's see. First, on the left side, I would distribute the 3. So it would be 2 plus 6x minus 21. On the right side, I would distribute this as a negative 4. So I'll have a 9, and then I'd think negative 4 times positive 3x would give me negative 12x, and then negative 4 times positive 1 would give me negative 4. Still simplifying here, I'm going to combine my like terms, 2 and negative 21, so I'll have 6x minus 19. Here, when I combine my like terms, 9 and negative 4, I'll have negative 12x plus 5. Okay, I'm done simplifying each side. Now what I want to do in step 2 is get the variable terms all to one side, and it's usually easier to move the smaller variable term. Well, 6x and negative 12x is the smaller variable term, so I'm going to add 12x to both sides. Come over here to finish this. 6x plus 12x would give me 18x minus 19 equals 5 on the right side. Now that I've got the variable all by itself on one side, now I want to get rid of these terms to get x all by itself. So I'll get rid of the 19 first, undo the subtraction first. So then I'll have 18x is equal to 24. Now I'm going to divide both sides by 18. And x is going to be 24/18. That's an improper fraction. It's okay to leave that improper, but we can simplify these. Notice they're both even numbers, so at the very least I could take a 2 and divide a 2 into each of these. If I divided the top by 2, that would give me 12. 18 by 2 would give me 9. I can still simplify that because there's a common factor of 3 hiding in 12 and 9, so I would divide that out 4/3. So this would be a fine answer of 4/3. We could turn it into a mixed number if you wanted to, 1 1/3. But I honestly think this is a better answer because the very next thing we're going to do is we're going to have to show a check with this answer, and 4/3 is much easier to check with than this 1 1/3. So either answer here is good, but this one is the desired answer now that we're working with equations. All right, let's look at question 22 now, where we're supposed to check this. So here was our problem. Our answer was 4/3. We want to check to see if that solution is correct. So what we're going to do is we're going to take this 4/3, plug it in here where we have an x, and simplify each side and see if we get the same answer on both sides. So let's see, 2 plus 3, 2 times 4/3 minus 7 equals 9 times 4. And then let's see, 3 times 4/3 plus 1. Okay, I want to talk about what's going on right here first, because this is not actually going to be that hard to multiply 3 times 4/3. Because look, if I have 3 times 4/3, I think of 3 as a fraction. It's 3/1 times 4/3. Notice what's happening there is this common factor of 3 is dividing out nicely for us, and we don't have to multiply a whole lot there. That's just going to give us an answer of 4. That's really nice to not have a fraction anymore. So let's write that in there, minus 4. This is going to be 4 plus 1. Okay, let's take a look at this other side here. I'm going to start here in the parentheses, again with this multiplication. Now 2 times 4/3. Think about this 2 as 2/1. So I'm going to take 2 times 4, which would give me 8/3 minus 7, 3, 2 plus. Okay. So we've got the first multiplication done. We're still simplifying these sides. I'm going to erase this to make some room here. Now, on the right side, I would start by just adding this 4 plus 1 together. I'd work in the parentheses. But on the left side, notice I'm going to have to take this fraction 8/3 and subtract 7 from it. That is not awesome to do. That's no fun to do. So in both of these situations, I had a choice. I could either figure out what the answer was when I did this addition inside the parentheses or the subtraction inside the parentheses and then multiply what's out front. Or I could have used the distributive property to distribute the 3 here and here, and it's going to work out the same answer either way. On the right side, it was better to add these 4 and 1 together to get 5 and then multiply it by 4. That's easier than using the distributive property. But on the left side, it's going to be easier to distribute this 3 first. The reason is, if I take 3 times 8/3, the fraction goes away. Because notice I'm taking that 3 times 8/3. Well, look, this is the same scenario we just had. Look at those 3's divide out for us, leave us with an answer of 8. So on the left side, I'm not going to subtract. I'm going to distribute because it makes it easier for me to do the problem. So I'd have 2 plus, we said this already, was going to be 8. And then I'll take 3 times negative 7, which is negative 21. Okay, still working to simplify this. Let's see. On the left side now, let's go ahead and do one more step. Let's do the 2 plus 8, which would be 10 minus 21. On the right side, let's multiply here. 4 times 5, which is 20. So that's going to be 9 minus 20. 10 minus 21 is going to give me negative 11. And then 9 minus 20 is going to give me negative 11. So that problem checks out. All right, question 23. A person who buys stock in a company is called a shareholder. Shareholders earn or lose money alongside the company. Shareholders can also earn money in the form of a dividend, which is an amount paid to them per stock. Dividends are often paid at the end of the year. So the reason they have dividends is they want their shareholders, the people investing in the company, to hold on to the stock. It's better for the stock price if people buy the stock and hold on to it. In this case, they hold on to it long enough, then they earn a dividend. So that's why companies pay these dividends. So let's see. Walt Disney pays 35 cents annual dividend. It means that every year you get 35 cents added to your account, basically your value of your stock account with them, if you hold on to their stock, because they'll pay you a dividend. Okay, on this particular day, the stock price closes at $95.17. So now we're going to fill in this chart to figure out how much money people have in this Walt Disney Company at the end of this day, where they've paid this 35-cent dividend and the price of the stock is $95.17. So let's see, for 200 shares, if we pay 35 cents per share, all we got to do is take 200 times 0.35, and that would tell us that that is $70 for the dividend paid. Now, to find the value of the stock, we're going to take 95.17 times 200, so 95.17 times 200. So that is $19,034. So the stock value there is $19,034. So then the total value then would be, if I add those two together, so 19,104. Okay. Investor 2 has 340 shares. We're going to follow the same process now. Take 340 times 0.35, the dividend paid, and we get 119. And then if we take 340 times the value of the stock, which was 95.17, that is going to be 32,357.8. Add those two together, and we're going to get 32,476.8. So I'm going to stop there. You get the idea. So what we're doing is we're just taking the number of shares we have. First, we're going to multiply it by this dividend to see how much the dividend then is worth. And then we're going to take the number of shares and multiply by the stock price to see how much the stock price is worth. Add those two together to get an amount of money for this account. And so that's the kind of situation we want to reproduce down here in part B with our equation. We want to do just that. We want to take the number of shares, multiply it by the dividend, take the number of shares and multiply it by the stock value, then add those two together to get a total value. So down here it says write an equation for the shareholders, and we're going to use V as the value and X as the number of shares owned. So V is the value of the stock, and then X is the number, X here is the number of shares owned. Okay, so let's see. So we said first we're going to take this X and multiply it by the dividend. So that would be 0.35X. Then we're going to add it to 95.17 and multiply that times X. So there is our equation. We would take the number of shares we have, first multiply by the dividend price, 0.35. Take the number of shares we have, multiply it by the stock price, 95.17. Once we get those two values, we'd add those together to get a total value of the account. Okay, part C, use your equation to determine the value of a stockholders if they own 500 shares. So we'd say, all right, V equals 0.35 times 500 shares plus 95.17 times 500 shares, and then this will give us the value of the account. So 0.35 times 500 is 175, and then 95.17 times 500 is 47,585. add the 175 to it, and we get the value is 47,760, and since this is money, let's put a $sign on there. Okay. Question 24. The volume of a rectangular box can be calculated by using volume equals length times width times height. Calculate the volume of this rectangular fuel tank. So we know volume is length times width times height. So let's see. That's going to be the length is 40. The width is 10. And the height is 15. So all I have to do to calculate the volume of this box then is multiply those values together. So 400 times 15 is going to give me 6,000. Now with volume, we measure volume with little cubes here. So that's, remember we measured area with squares. We measure volume by how many of these little cubes it will take to fill up this tank. So these cubes are 1 inch by 1 inch by 1 inch, or a cubic inch. So that's what we want to say down here for 6,000. We would want to say cubic inches, because it would take 6,000 of these little cubes that are 1 inch by 1 inch by 1 inch to fill up the volume of this tank. All right, part B. Let's see, I'm going to keep the picture of the tank in here a little bit too. To construct the long sides of this tank, so the long side of the tank, which is right here, this is the longer side of the tank. A large piece of aluminum 40 inches by 50 inches was folded 3 times and welded together. So what we're thinking about here is creating this part. Let me scroll up here just a little bit. We're making this part of the tank right here. And then we've got these 2 ends to deal with. So the way they make this part of the tank is they fold the aluminum over and weld it in one spot. So it would kind of look like this. Be a long piece of aluminum, longer than what I'm drawing here. But this fits on my screen. And so this is 40 inches this way. And they're telling me 50 inches this way. And what we do is we fold this thing in 3 places. My folds aren't perfect. They should be the same distance every time. So let's change this fold a little bit here. So I'm closer. We're just getting the general idea here. So what they do is they fold that tank over 3 times, and then what they do is they weld this side to this side. And if you can visualize that folding up, it makes this shape right here. Then what they do is they put these ends on there. So we got these little rectangular ends that are 10 by 15 that go on the ends. So we have 2 of these, 1 on each side, 10 by 15. That fits on the side here. You know, so we fold this tank up, and then we put these 2 ends on, weld those 2 ends on, and that's how they make that tank. Okay, so draw a picture of the 3 pieces of aluminum that were used to make the tank. And so I've done that right here. We've got this one piece that gets folded up, and then these 2 end pieces. Okay, so let's move on to the next question now. The area of a rectangle can be length times width. Calculate the total area of all the sheets of aluminum that were needed to construct this tank. Well, we scroll back up here. The area of this rectangle is length times width, so that will be 150. I'm going to write it right here. 150 plus area of this smaller rectangle is also 150. Then I want to find the area of this bigger sheet that we use to make most of the tank, and that is 40 inches by 50. So we take 40 times 50 there. And that's going to give us 2,000. Okay, so let's scroll down to the question now. So 150, 150 plus 2,000. Well, 150 plus 150 is 300. So that would be 2,300. And now we're measuring area here, so that is square inches. Okay, so that's how much area of this sheet aluminum it took to make or construct this tank. The thickness of the sheet aluminum used on this tank is 0.0125 inches, and the cost is 8 cents per square inch. What is the cost of the sheet aluminum used to make this tank? Well, We know that it takes 2,300 square inches of aluminum to make the tank. We know the cost is 8 cents per square inch. That's all we need to calculate the cost. We don't really need to know that this aluminum is this thick when we're determining the cost of it. We might use this in terms of the construction of the tank. That information might be valuable, but it's not valuable here to find the cost. So what I just need to do is I need to take this 2,300, multiply it, times the cost per square inch. So I take 2,300 and multiply it times 0.08, and that tells me it's going to cost $184 exactly to pay for the aluminum for this tank. All right, section 3.5, the first question we're going to look at is question 7, and what we're trying to do is solve for this variable h. Solve means we want to get h all by itself. So one thing that we can do anytime we have an equation, we have a situation where we can get rid of the fractions in the equation by multiplying by the reciprocal of that fraction. So notice I've got this 1/2 in here. It would be nice if I didn't have 1/2 in my equation. Well, look, if I take 1/2 and I multiply it by 2/1, do you see how nicely those 2's divide out for me? And it gives me a value of 1. I'm going to use that idea to make this equation simpler by getting rid of this fraction 1/2. So what I'm allowed to do in an equation is multiply both sides of the equation by the same number. So if I do this very thoughtfully and carefully here, if I take this side of the equation and I multiply by 2/1, and I multiply this other side by 2/1, I'm still going to have a nice balanced equation, but what that will do is it's going to get rid of this fraction for me here. So let's see, this was supposed to be a 1 there. 2/1. Now, when I go to multiply, I can multiply this number times h, b, or 1/2. Well, it's going to be best if I multiply by 1/2 first, because as we already said, if I take that times 1/2, it's going to give me 1. So what I'll have left on the right side here is just 1bh, or just bh. On the left side now, I'm going to take essentially 2 times a, which will give me 2a. Now that I've cleared the fraction out of this equation, it's going to be easy to solve for h. We want to get h by itself. The only thing that's keeping it from being all by itself is this multiplication of b. So to undo multiplication of b, I divide by b. And so I would say now that h is equal to 2 capital A over b. Question 11. Using the formula for simple interest, I, interest, equals the principal times the rate times the time. Calculate the simple interest you would earn of $3,600, where the simple interest rate is 4.5%, and we're going to keep this in this account or investment for 3 years. Okay, so we'd say, all right, interest is going to equal the principal, which was $3,600, times the rate, which is 4.5%. Well, 4.5%, we want to turn that into a decimal first. The way we do that is we move the decimal 2 places to the left. So that is actually going to be 0.045 for my interest rate there. Okay, so I'm going to put 0.045 in there for that one, and then the time is 3 years, so times 3. So then that will tell me the interest that I'm earning on this account. So I take 3,600 times 0.045 equals 162 times 3. So that's going to be $486. So let's put a $sign on there, 486. Okay. Part B, calculate the ending balance after 3 years by adding the interest earned to the principal investment. Well, here was my principal investment. Here's my interest earned, so I'm going to take 486 plus 3,600 to give me then a total value here of $4,086. Let's put a $sign on that since it's money. Okay, let's Let's take a look at question 12 now. Now we're going to use the compound interest formula. This is the amount of, A is the amount of money in the account, P again is the principal investment, 1, R is the rate, N is the number of times it gets compounded a year, which means the number of times they calculate the interest per year. And then up here it's N again times T, and T is the length of time that we have, which in this case is going to be years. So we're going to use this formula to calculate the balance on a principal investment, same investment, $3,600, same interest rate, 4.5%, same time frame, which is 3 years. The only difference here is that we're going to compound this interest now 12 times per year, so that's going to be our N value. So let's see, we would say A is equal to 3,600 times 1 plus same interest rate, 0.045. We don't want to put that in there as a percent. We got to put it in as a decimal number, just like last time. N we said was 12. And then up here, I'm going to have 12 times 3. Now, when we go to calculate this, we want to do it all at once, because we don't want to round these values as we're calculating. It will significantly change our answer. So what we do when we're doing these compound interest formulas, first thing we do is we get an answer to the exponent, which is 12 times 3, or 36. Once I get right here, now I'm ready to plug all of this information into my calculator, and I want to do that so that I don't have to round anything. So what I do is I start in the parentheses here. I take 0.045 divided by 12. Hit equals. Leave that answer now in my calculator. I want to take that answer without rounding it and hit +1. So now I just hit +1 equals. So now I've got a nice long decimal number here, and what I want to do now is I want to take that decimal number to the 36th power. So on your calculator, you're either going to see something like this, x to the y. That means we're going to take this value to whatever power we want, or you'll see this little caret, a little arrow up. Both of those mean exponents. So on my calculator, it's x to the y, so I take the value that is currently in my calculator that I've already calculated, I hit the x to the y button, and then I hit the power I want to take it to, which is 36. If you had the caret key, you would just take the value that was in your calculator, hit the caret, then hit 36 and hit equals. Now, what that's doing is it's giving us a calculation for everything that's in here. So what I want to do is I want to take this value now and multiply it by 3,600. So I'm going to go times 3,600, and it's going to give me now an ending balance of 4119.29. So 4,119.29. So now question 13 says for us to compare the values to answer 12, which was this one, and answer 13, which is this one. And you'll notice that we get more money in this account here than we did in the simple interest. And the reason is, and this is what question 13 is getting at, the reason we earn more money here is because when interest is compound interest, which is most of the time the way interest is calculated, when interest is compounded, you actually earn money on the interest you've already earned. So as we're calculating this along here and we keep compounding this value, we calculate the interest based on the value, the current value of the account, which includes the interest we've already earned. In a simple interest account, you only earn money on your initial investment. You never get to earn money on the interest that you've earned. And so the difference here, this is linear growth. Simple interest is linear growth, meaning if we looked at the growth of our account, it would always be at a nice, steady, constant rate, growing in this way if we keep earning this interest, if this was a graph of it, you know. Here with a compound interest, since we earn interest on the interest, this is what the graph of our account looks like. It's exponential growth, and exponential growth grows to much greater values than a linear growth. In Chapter 5, we'll talk more about linear growth and exponential growth, but there's a little sneak peek at those two terms and those two ideas. All right, question 14. The perimeter of a rectangle is 350 inches. The width is 30 inches. What is the length? Well, so the perimeter of a rectangle, if we look at our formula, let's first draw a rectangle. So anytime we're looking at a math problem and they're asking about some sort of picture or something and they don't have the picture there, first thing we want to do is draw the picture and then put down the information that we know. So we know this. We know the perimeter is 350 inches. We know the width is 30 inches, so we know this is 30 inches. That's what we know. The picture is really going to help us figure the rest of the stuff out. Okay? So what we have here is this. A rectangle has opposite sides equal. So if this side is 30, well, what's this side going to be? Well, that's also going to be 30. Okay? We don't know the length, but we do know this length is the same as this length. Now, once we get there, we're ready to solve the problem, because remember, the perimeter of a figure is the distance that we travel around the outside of the figure. So let's think about this perimeter traveling around the outside of the figure. We know this, that the perimeter here is going to be this 30 plus, as we travel around the figure, this L here, that length, plus L, plus this 30, plus this L. Okay? Let's enter some more information here in our equation. So notice we had our perimeter here, which was 350. We have our equation here, which we can now simplify because we've got like terms. Look at L plus L, that's 2L. 30 plus 30, that's 60. Now I have a nice equation that I can solve. So I'd subtract 60 from both sides. And let's come around over here. I'll come down here to finish it. So let's see, when we do that, we'll get 290 there. And over here we'll have 2L. Divide both sides by 2. And I'll see that L then is half of 290. 145. So I know the length of this thing is 145. So we would say up here the length is 145, and we want to say inches on there for our answer to that problem. Now, another way to do this once we had our picture done here is use guess and check for L. You know this is 30, you know this is 30, you know these are going to be the same. You could use guess and check to find this answer. And that's an okay way to start, but what we're trying to transition to here is using algebra to find our answers. And that's a little different, because what we're doing with algebra is we just want to describe the situation with an equation, which is what I've done here. I look to first write the equation. Once I write the equation, the math gets taken care of for me, because notice the math I do to solve my equation is what gets me to my answer. So I don't need to worry about necessarily the steps that I'm using, or the math steps that I'm using to solve this problem. I just look to describe the situation with an equation. Once I do that, I'm kind of home free. I just follow the steps to solve an equation. It takes care of the math for me. So we said this one was 145 inches. All right, let's take a look at question 17 here. The area of a square, so think about this. We got a square. The area is 625 square centimeters. And that means it takes 625 of these little squares that are a centimeter by a centimeter to cover up this square. What is the length of a side? Ooh, this is a tricky question. Without a picture, it's going to be really hard to answer. So let's see. Let's draw a square. So what do we know about a square? We know the square is different than a rectangle, because actually a square is a rectangle. It's a special kind of rectangle where all the sides are the same. So instead of having a length and width here, really what we have is, you know, all the sides are the same. So we could think about this as S, 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 S. So we also know that the area is 625 square centimeters. And remember, area of a rectangle or a square is length times width. But in this case, all the sides are the same. So really my area is this, S times S. Or you could do L times L or W times W. That would be fine too. But the idea is that in this square, the sides are the same. Well, we can actually solve this equation now, given this information. And this is a tricky question, so you're probably not going to get it the first time out. So don't feel stressed if you weren't able to get this question. Most of the time, people have to see this question worked out once to get the hang of it. So let's see. Let me enter now. I've got my equation. Remember, that's what we try to do when we're solving with algebra, is get that equation. Everything else is going to get taken care of for us. Now let's enter the information we know in our equation. Well, we know that the area is 625. So I'm going to come over here and say 625 equals S times S. Well, another way to write s times s is s to the second power. S squared, we would say that. And we know that if s squared equals 625, there's an actual operation we can do to undo squaring something and solve this equation. So the opposite or undo operation of squaring something is the square root. So what I would do now is I would take the square root of both sides, and if you look on your calculator, you'll have this square root symbol. Well, what happens, the square root asks us what times itself gives us s squared. That's what it's asking. What times itself would give us s squared? Well, that's s. Because s times s gives us s squared. We just went through that right there. Now the square root over here is asking what times itself gives us 625. If you can think of that off the top of your head, that's great. If not, let's go to our calculator and figure out what times itself gives us 625. Well, all we have to do is enter 625 and then hit the square root key, and it will tell us that that is 25. Now we want to make sure we get some unit of measure on that 25. Let's see. This was square centimeters, so this is going to be 25 centimeters on each side of the square, meaning this, 25 centimeters, 25 centimeters. So there was our answer. So you're going to have some other questions like this in 3.5, but draw the picture and use this idea. You know, you're probably going to have s times s, probably have to use the square root here to solve for some of these things. Go ahead and try those problems now. You got a couple more like this on your work. All right, section 3.6. We're translating written statements into an equation and then solving that equation. So let's see. We want to do this in little chunks. When 3 times an unknown number, all right, let's stop right there. Let's say that x is our unknown number. And you could use n or some whatever variable you want to, it doesn't matter. So x is our unknown number, so if we take 3 times that unknown number, it would look like this, 3x. When this is subtracted from, well, notice we're subtracting 3x from 20. So we actually want to reverse the order here than what it's written. We're subtracting this 3 times this unknown number from 20, so it looks like this, not the other way around. The result is 16. Once we have our equation written, we can go ahead and solve this. Subtract 20 from both sides, and then I'd have negative 3x. Negative 3x is equal to negative 4. Divide both sides by negative 3. And then we would say x is equal to 4/3. Okay, question 7. The sum of an unknown number, well, we got another unknown number, so let's let x equal this unknown number. Okay, x is our unknown number. When the sum of an unknown number and itself, so let's think about that for a second. Again, we want to do these in little chunks. What does it look like, the sum of an unknown number and itself? Well, that's telling us to take this unknown number and add it to itself. Okay? Now we want to take that sum and multiply it by 4. Notice if I put a 4 right here, it's only going to multiply just this x. This thing is asking us to take the whole sum and multiply it by 4. So the way we do that is we put this sum in parentheses, put the 4 out front. Now we've got this 4 multiplying the sum of the two numbers. The result then is 56. Again, this is a little tricky step right here. The first time you see it, you might not get it. But so anytime we want to take and multiply a number like 4 or something times the sum or the difference of something, we got to put that sum or difference in parentheses so that we're taking 4 times that whole thing. Once we get here, we can go ahead and solve this. Let's see, we have add the x and x together to give us 2x times 4. So then it would be 8x equals 56, divide by 8. And x, let's see. Oh my goodness, I can't remember what that is. Is that 7? 7, 8, 48. 8 times 6 is 48. Yeah, that's right. 7. Struggled a little bit there. Got it. Okay. Let's see. In 2015, the average weekly salary for workers in the United States was $801. So let's stop right there and think, okay, you see the average United States worker, and they get this average salary of $801 a week. This average weekly salary amount is increasing by $24 after 2015. So in 2015 we were making $801 a week. After that, we're going to increase that every year by $24. We want to write an equation for that. So this average weekly salary. So let's maybe do S for salary. And what we want to do is we want to take this 801 plus $24 per year. So we would need 24 times maybe Y for years. So that way, every year after 2015, we would take that year and multiply by 24 and increase our salary. So we need to define what Y is. It's not enough to write this equation. We got to tell our readers what Y represents. And Y here equals the years after 2015. Can't just say that Y is the years, because that would mean we're taking the number of years in 2016, then Y would be 2016, right? Not 1. So we want to make sure we define our variable here that Y is the years after 2015. That way when we get to 2016, we would use a 1. 2017, we would use a value of 2 here in our equation, 3, and so on. So it's important that we write the equation, but it's also just as important that we define our variable here so that we know what that variable represents. Okay? Part B, in how many years after 2015 will the average salary reach, the average weekly salary should be, reach this? And which year will that be? So let's go ahead now. This is the salary, so we're plugging that into our equation for S. So we got 1,107 equals 801 plus 24 times Y. We're going to solve this equation for Y. So subtract 801, 24Y. Let's see. 1017 minus 801 is 216. Divide that by 24. Nine. So we get here that Y equals 9. That's good. Now they ask us, in which year will that be? Well, remember, Y is the years after 2015. So we are going to take 2015 and add it to Y, and that would give us 2024. The average worker makes 1,017 per week. And we want to put a $sign on that since we're talking about money. Question 12. In preparing for spring break trip with your friends, your job is to rent the car. Rental option 1, we can rent the car for $48.50 per day with unlimited mileage. Rental option 2, $27.75 per day plus 11 cents per mile. Your trip is going to last 7 days, and we think it's going to be about 1,600 total miles. So we want to write a cost equation for each of these situations. So let's see. Let's look at rental option 1. The cost of rental option 1 is going to be $48.50 or 48.5 times the number of days we rent. So it would just be D. We don't want to put 7 in there at this point because we're writing an equation with a variable in here. Over here now we're going to put the actual cost. So then we would figure out that we're just going to take 48.5 times 7 days, because we said we're going to go on this vacation for 7 days. So we take $48.50 times 7, and that's going to be $339.50. Let's put a $sign on that. So that's the cost for that one. Let's look at the next one now. Let's write a cost equation for rental option 2. Oh, sorry. Up here I should have said that D equals the days to define my variable for the reader. I should have put that in there as well. D is the days. Let's see. cost equation 2, we got two things going on here. We've got 27.75 times the number of days plus 11 cents per mile, so 0.11, and let's use M for miles. So we'll say, okay, in this one, D equals days, and M equals miles. So the number of days times 27.75, and the number of miles times 11 cents per mile. There's our cost equation for that. Now I want to come over here and fill these things in. So I'll take 27.75 times the number of days, which is the same, 7, plus 0.11 times the number of miles, which we estimated to be 1,600. Let's see what our cost was here. So we got 27.75 times 7. And so that gives us 194.25. Now let's add the miles on here. 1,600 times 0.11 is $176 for the mileage. So let's add that back now to the 194.25, and we get $370.25. Okay, so it's a good thing you did your calculations here. You're going to save your friends some money. You're going to save $30 by taking just unlimited mileage and the 48.50 per day option. Okay, we're going to do the 3.6 class project in chapter 3. So let's take a look at this together now in the video. So the manufacturer's retail price, I'm not sure what the S is for, but the manufacturer retail price of the Ledge all-wheel drive is this. So if we buy this thing right off the lot, it's $34,145. So we're either going to purchase or lease this vehicle. You don't currently have this $34,000 in your pocket, so you're going to need to borrow money to finance the vehicle. To purchase the car in 5 years, we need to pay a 10% down and have payments of $627. To lease the car for 4 years with a yearly mileage limit, so we got a yearly mileage limit of 15,000 miles, we need to pay $4,382 at the lease signing and a monthly payment of $322. Fill in the pricing chart for leasing and purchase costs. We're going to exclude tax license fees, but include the down payment cost in the first month. Okay, a lot of stuff going on here, so let's just focus on this one. This is going to be just our costs here to lease. This will be my payments for lease, and then also our payments to purchase. Let's start with the lease here. So let's see. Total charge for the lease. Well, the lease is going to be this. We got to pay $4,382. So $4,382 plus a monthly payment of $322 is going to equal $4,382 plus $322 equals $4,704 for our first payment. So our first monthly payment is going to be $4,704. Now, from here on out, we don't have to keep paying this $4,000. That was just due on the day that we signed the lease and took the vehicle. After that, we're just going to have this monthly payment of $322. So what we want to do to get our next payment is just take this $4,704 plus $322, and this will give us the running total now. So plus $322 will give us the running total of how much money we're investing in this lease. So $5,026. That's how we're going to fill out the rest of this. Okay, that's the cost for lease. Now let's look at the cost to purchase. So the cost to purchase, we have to make a payment of $627, and we have to put 10% down. Well, let's figure out what 10% down is of this price of the vehicle. Well, we know the price of the vehicle was $34,145. We want to take that times 10%. Well, 10%, remember, take the decimal and move it 2 places to the left to turn it to a decimal. That's 0.1, or 0.10, either way. So we're going to take 34,145 times 0.1 or 0.10, and that tells us we are going to have to make a down payment of 3,414.5. So there's our down payment, plus we have to make this first monthly payment of $627. So the first month is going to be expensive. 4,041.50 cents for that first month. Now, we don't have to make the down payment anymore. We just have to make this monthly payment. So the running total here for the next line is going to be take this value, add 627 to it, add 627 to it. That's how we're going to get our running total. Now let's look down here at the equations. Write two equations. One equation for the lease, one equation for the purchase. So let's take a look at this equation for the lease. So the cost, they say to let C represent the cost and M the number of months. So how are we coming up with this total cost here? That's how we're going to write our equation. Well, what we had to do is we had to take this payment at the lease signing, $4,382, right? Plus then this payment of, what was it, $322 per month. So $322, how would we make that a $322 per month, or the number of months we're taking? Well, we would just take that times M, like that. And so this cost equation will reproduce these values that we're getting. Notice at the end of the first month, we would take our lease signing, $4,382, plus we would add $322 one time, because we've had the car now 1 month. So M would be 1. After 2 months, M would be 2. So we'd be taking this 4,382 plus 322 twice. 322 3 times, 322 4 times. That would give us the running total of our lease. We want to do the same thing over here for the purchase equation. Same thing I did for the lease now. You want to do that for the purchase equation. Once we have our equations here, we're going to be able to use our equations to make these calculations. For example, use our equation to determine how much it costs to lease the vehicle for 4 years. Well, 4 years, all we got to do is plug in the right number of months here in this equation, and this equation will spit out how much it's going to overall cost for having this car for 4 years. And then here we could say, how much does it cost to purchase the vehicle? Purchase the vehicle now in 5 years. So we'd use the purchase equation, plug the number of months for 5 years, figure out how much that costs. Then from there, you can say, if you're forced to choose which option is better for you, go ahead and choose it, and then explain your choice. Last question here is about the purchase. If we just spent straight out of the gates, we'd saved up this money and bought the car, purchased it right off the lot, it's going to cost that much. If we finance it like we did, you can use now your purchase equation to figure out how much the overall cost would be and how much extra money we're going to have to spend to finance the vehicle. All right, section 3.7, question 35. We're trying to solve this equation for M. Well, right now we're adding 5/6 to it, so we need to undo or get rid of that. So we would subtract 5/6, subtract 5/6 from both sides. On the left side, we're going to have M all alone. Perfect. The right side, we got to do a little work here with the fractions. We have to get a common denominator. 6 and 12, that common denominator is going to be 12. So I'm going to think about this as negative 11/12. Notice I took that negative sign and moved it to the top. It's still a negative value over here, because notice a negative divided by a positive is still negative. Moving that negative sign to the top is going to help us when I go to add these fractions. With the 5/6, I got to get a common denominator of 12. So I'm going to multiply this thing times 2 times 2. This is going to be negative 10/12. So I'm adding these guys together. Negative 11/12 plus negative 10/12 is negative 21/12. That's a good answer, but it's not simplified, so we need to keep going here. So let's see. There's a common factor of 3 hiding in each of these numbers. So that's going to be negative 7/4 for my answer. This would be a fine answer, or if you wanted to turn that into a mixed number, we would have negative 1 3/4. All right, question 58. Using the formula for compound interest, we're going to calculate this thing out. So let's see. Our principal, P, is 4,200. So let's see. Our amount of our account is going to be 4,200 times 1 plus the interest rate, which is 3.5%. If I turn that to a decimal, I'd move the decimal 2 places to the left. So that's going to be 0.035. The number of times it gets compounded, n, is 12. So that's what's going to go right down here, 12. And then I'm going to take n, which we said was 12, times t, and the t in this case is 4 years. So I'm going to set myself up to calculate this without rounding anything. So what I do is I first get that value of the exponent. So 12 times 4 is 48. Once I get here, now I want to do all of this calculation without rounding to get my final answer. If I round along the way, I'm getting an answer that's not accurate. That looked like a 0.12 there. That's just 12. So let's see. 0.035 divided by 12, hit equals. Take that answer now, plus 1. And that does then is I've got an answer for what's in the parentheses. I don't want to round this. I want to keep that value just what it is on my calculator. I want to take it to the 48th power. So I'm either using x to the y on my calculator button or the little caret button. Either one, I'm going to take the answer that's in my calculator, hit the caret or the hat, sometimes people call it, or the x to the y button, punch that one, and now I want to hit to the 48th power and hit equals. So then what I'll have is I'll have a calculation for all of this right here. And notice we're going to take all of that and multiply it times 4,200. So I take my answer on my calculator right now and hit times 4,200 to get my final answer then. Put a $sign in front of this since this is money, is 4830, and we round money to the nearest penny, so that would be 1/7. Okay?